Welcome to Chapter 17, Part 1. Chapter 17 and 18 go together. We're going to be talking about a new functional group, the aromatic compounds. And in Chapter 17, we spend a lot of time, we go through some nomenclature, and we talk about structure and stability and what aromaticity really means. And then in Chapter 18, we go into reactions, mechanisms, predicting of new products, and a little bit of synthesis. So with Chapter 17, let's just start off talking about kind of our basic aromatic structure, the benzene ring. All right, so anything that contains benzene in it, this benzene moiety, is considered aromatic. Benzene derivatives, like what you're seeing here, these are some fairly simple structures. They're also sometimes referred to as arenes or aryl groups. There are lots of different words that we might use that will indicate that there's this aromatic ring. They were originally isolated from oils that had strong smells, which is why they're called aromatic, but not all aromatic compounds smell. In fact, most of them don't, but the name stuck. They are present just like any of the other functional groups that we focus on in this organic 1 or 2 class. They're found all over the place, right? So you see aromatic rings in tons of different pharmaceuticals. You see them in nature. You see them in, let's see, what are we looking at here? In coal, graphene, right? There's you see this system in a lot of places. Now, let's talk about naming. Nomenclature. If you are dealing with fairly simple substituents, then the parent, right, is going to be whatever the substituent is, benzene. And if it's monosubstituted, you don't have to say where it is. It's a ring. It's automatically wherever the R group is carbon 1. So you don't have to put it. So some common, some easy to name ones, right? Halogens, you have halobenzene. The NO2 group. Depending on your organic 1 experience, you may or may not have named the substituents. So let's make a little list of substituents you should know that may or may not be new. NO2 is a nitro. Nitro groups are never the parent. They're always a substituent. So you should know that name. Your alkyl groups, that you definitely should know from organic 1, just like the halogens. A few others that you might, depending on where you hit alcohols, if you hit it or not in organic 1, an OH group, if it is the substituent, is a hydroxy group. And if you're dealing with a little ether, this is an alkoxy. So, for example, if it was OCH3, well, that's based on methane, so it would be methoxy. You should know how to name these. Another one that will come up in this chapter, in H2, this is an amino group. Right? So if you don't know how to name these substituents, add this to your note cards, your study session, whatever. I'm not going to write these down on the right, but you should write these down in your notes. Make note cards, however you memorize things. You need to memorize these 8, and there will be a 9th as well, but we're starting with the monosubstituted. these 8 common names. Whoop, right here. If you have a methylbenzene, the common name is toluene. Hydroxybenzene, common name is phenol. Methoxybenzene, common name is anisole. Aminobenzene is aniline. So as you're writing these down, let's talk about these. We'll move down here in just a moment. Let's talk about these. Now, if I asked you for a name, you could give me methylbenzene or toluene. But if I ask you a question using the common name, you need to know what it is. So you have to learn these. The next 4, we don't know how to name this as a substituent, so you really only can know the common name for now. Benzoic acid. So we have a 1-carbon carboxylic acid on our ring, benzoic acid. If we have the aldehyde version of that, it's benzaldehyde. Now, if you have a ketone and on one side is a benzene ring and one side is a methyl, this is acetophenone, something that you should start recognizing. ACET is going to always accompany a methyl group next to a carbonyl. Acetone just has another methyl group on the side. Acetophenone has a phenyl or an aromatic ring on the other side. Acetic acid would have an OH. You are going to see this prefix in a lot of common names. And then styrene. Styrene has a 2-carbon unsaturated double bond attached. So please commit these to memory. They will show up in nomenclature problems. Okay, now what to do if benzene isn't the parent. If it's not the longest continuous chain, or if there are other higher priority functional groups present, then a benzene ring attached to whatever the parent is would be a phenyl group. This can be abbreviated with a pH, like you see here. That is used frequently because benzene rings get bulky and time-consuming to draw. If it's not what you are interested in a mechanism, a lot of times it'll just be abbreviated. I'm always a little bit confused here. This little symbol, the phi symbol, could also be used. Aside from this portion of this textbook, I don't ever see that used. Before we move on to dye substitution, another substituent that I want you to know that's not in this book is this guy. It's a benzene ring, but instead of being directly attached to the parent, there is a CH2 present. So this is the whole substituent we're looking at right here. So it includes that CH2. This is a benzyl group. It might be abbreviated with BZ. I think it's important to know both. The benzylic position is that CH2 next to the ring, and that'll be important later. But also because people often mistake benzyls for phenyl. So it's important to recognize the difference. So if we were going to do a practice problem here, let's say we have, let's just go ahead and make a longer chain so we know it's not the parent. If we have something like this, and our parent is 1, 2, 3, 4, 5, 6, 7, is heptane. This would be a 3. In fact, let's put this at 4 here. There we go. This would be a 3-benzyl 4-phenyl. Okay, let's try that again. There we go. Heptane. All right, so you definitely should know the difference here. Now, dealing with di-substituted benzenes. There's only one common name that you should know. Well, and then a set of common prefixes. And that's the xylenes. Xylenes have 2 methyl groups. And so there are 3 different isomers. 1,2-xylene, 1,3-xylene, 1,4-xylene. You could call it dimethylbenzene, but like with some of the other common names, xylene is much more common. If you buy a bottle, you're going to see xylene on the label. Now, a lot of times when you buy a bottle of xylene, it's xylenes because it's a mixture of the 3. Now, something that you may have been seeing since you started taking organic are these prefixes ortho, meta, and para. This is only applicable. Ortho is a 1,2 substitution. Meta is a 1,3 substitution. Oops. And para is a 1,4 substitution. You could also use just O, M, or P. This is only to be used with di-substituted benzenes. This is not to be used with cyclohexanes. This is not to be used with any other cyclic structure. It is benzene rings with 2 things present, and that's it. So there are several ways you could name these guys. It could be orthoxylene, O-xylene, 1,2-xylene, orthodimethylbenzene, O-dimethylbenzene. And the same could be said for the meta and the para isomers. Now, if you have a substituent that gives you a common name, then you're going to use that common name, right? So here, you could name this, a nitromethoxybenzene, but OCH3, right? If we look at this, this is anisole. So this is a nitroanisole, and I can call it 2-nitroanisole, but ortho is something that's very widely accepted. Now, if a substituent gives a common name, automatically that substituent is on carbon 1. All right, so this is 1 because it's anisole. Here, the common name is toluene, so this is carbon 1. Benzaldehyde. This gives it the common name, so this is carbon 1. 1, 2, 3, 4. All right, you want to make sure that you practice. Now, if 2 substituents give common name, I have seen mixed emotions about this topic. So, for instance, we have a hydroxy and a methyl. It would be correct to call this meta-methyl-phenol, but it is not ambiguous to call it meta-hydroxy-toluene. Both are acceptable. You might find in some books or some websites that they prefer this guy. And so I believe what they're doing is they're choosing kind of that higher priority functional group to give you the common name. And so the priority functional groups can be found listed if you just search nomenclature priority, or the other explanation could have to do with atomic number, and they're assigning priority similar to like the Coningle-Prelog rules. It doesn't matter. They're both correct. It's not confusing. Meta-hydroxytoluene is going to bring you to the same structure. So I would accept either name if I ask you to write out or type out the name of a compound. So for me, these are both great. Now, anytime we do nomenclature, you guys, we're going to see this list. Identify the parent, identify the substituents, give numbers, list in alphabetical order. Ignore those prefixes except iso when listing alphabetically. So like don't take into account di, tri, tetra. Right? This is just a review of nomenclature rules. If this was not a good enough review, this is where you need to go back and make sure you brush up on some basic nomenclature rules. If you have 3+ substituents on a benzene ring, you do not use meta, para, ortho, meta, and para. You've got to use numbers. So, for instance, when we are looking at this guy here, in fact, I'll just draw it again. I'm going to go ahead and I'm going to choose the substituent that gives it the common name because we have one in this case. This is a phenol. So that means this is carbon 1. Now, whether I number to the right or to the left, it's irrelevant. I have a bromine on both sides. So I'm going to have a 3,5 dibromo phenol, right? Nothing mind-blowing about that. Just walking through the naming here. Now, before we move on, I want to talk about, just to review a little bit of basics here. Let's say we were dealing with, let's pick one we haven't used yet. Let's say that we had this scenario. Now, whether you go to the right or to the left, you're going to get 3, 5. If there is a tie to be had, the very last tiebreaker is the alphabet. So I'm going to number clockwise simply because B comes before C in the alphabet. This would be 3 bromo, 5 chloro, aniline. If it were, let's say, let's maybe use styrene. If it was ClBr, right? Alphabet's your last tiebreaker. In this case, low cancer, or you're going to go clockwise just because that's going to give you a 2, 3 instead of a 5, 6. But you would still write it down alphabetically, right? 3 bromo, 2 chloro, styrene. If we name these molecules all over here, just for some practice, these are di-substituted, so we can use ortho, meta, para. We have a para chloro benzaldehyde. We have a meta bromo toluene, and we have a ortho nitro anisole. Notice you can use numbers or you can use the letters, or you could write out meta, para, ortho. Now, before we move on, and the last thing I want to talk about in this video is just another practice problem that I love to end with. We're going to have a CH3. Name this along with me. Now, nitro groups don't impart a common name, but the methyl group does. So if this is 1, we can number to the right or the left. It doesn't matter. We'll go counterclockwise just to mix it up a little bit. This is 2, 4, 6, tri-nitrotoluene. Oh, and do you recognize this molecule? It's okay if you don't. But you've heard of it before. This is TNT. Right? This is compound in dynamite. Oftentimes when you put a nitro group on a benzene ring, it creates something that is very reactive or explosive. Now, we nitrated a benzene ring in our lab, nitration of methyl benzoate. Maybe you did it online, but we often do it in lab. That is one of the safest ones we can do. Of course, we're not going to be making explosives in our sophomore level organic lab. But when you do nitrations, you put these nitro groups on benzene rings, you have to be really careful because you might create something that's very, very reactive. And so that's where I like to end you with nomenclature. We will talk more about structure and aromaticity in part 2.